To introduce the CALDER HYDROPRO hydrostatic system for use, the components and the system that we use today. The unit directly in front of me is a HYDROPRO console. It's capable of either a 10,000 PSI or 6,000 PSI system. This particular unit is fully loaded. I can actuate valves. I can control multiple ports, up to 4 ports of pressure. Today, the configuration what we have is this unit is actually tied to 2 different clamping consoles, and I can control both of those from the one unit here. Next to it is the CALDER Smart Test DOS. It's a data acquisition system that monitors the instrumentation that's needed, whether it be temperature, pressure, or a multitude of displacement or any types of parameters that you intend to monitor with instrumentation. This can be displayed. Comes standard with 4 ports, can be extended to 8 ports. An indicator, here's pressure transducer tied right to the console itself, so they can be used in conjunction with each other, but they can also be done independently. So you don't have to have one to have the other. Likewise with the universal straight valve clamping table system back here, the particular one we have today is a USB 12-150T. That tells me it's a 1-inch to 12-inch clamping table with 150-ton clamping capacity. It's a tilting option, so it allows me to fill the valve and allow me to do some other additional tests that a non-tilting unit doesn't allow me to do. To explain the patent pending safety interlock system on the Universal Straight Valve Tester, or the USV, you can see the valve alignment here, and it's a mechanical interlock system that you have the 2 drain valves attached to the clamp interlock release. What this does, it forces you to be able to open the drain valves and release any internal pressure that's hydrostatically applied to the inside of the valve. So by opening both drain valves, you can see it now allows me to open up the hydraulic clamp interlock. So this action actually releases any internal hydrostatic pressure, and then I can, before I release the lock, what I need to do is back off the clamp pressure control valve. I still have 2,800 psi of clamping pressure on the valve itself. Valve's tied to the overhead crane. I eliminate the air pressure to the clamp pressure control, and then all I have to do is just now release the clamp pressure. Now that pressure goes to 0. The seal plates stay in place until I use the ram rapid and retract the movable seal plate. Every clamping table comes with a clamping chart affixed to the face of the console. In this particular one, this is a USB-12-150T. It can test a 1-inch to 12-inch valves. Tells me the valve size on the side. If I look across the top, I see the ASME class of flange for rating. I also see the associated hydrostatic test pressure for each one of those pressure classes. So the information is right here on the table. What's in the chart's populated with the actual hydraulic pressure needed to seal that size and that pressure class for a hydrostatic test. So in this case, let's say I have a 6-inch 150 or 150 class flange. So I would come here to 6-inch, go over to the 150 class. This tells me I need 700 psi of clamping force to seal that valve to run the hydrostatic test. My hydrostatic test pressure would be at 450 psi. So all the information's here, right here on the machine itself. The item we're looking at, every clamping table and every HYDROPRO console is fitted with an air handling system. This air handling system, what it does is it takes the inlet air from your shop, goes through a stop valve, and this stop valve can be in lockout, tagout, so we can isolate all the air to the source and cut the power to the whole unit. When I turn it on, what it does, it allows air through here. If there's any moisture in the air, we have a moisture separator unit right next to it that can be bled for any moisture in your system. Then it goes through a regulator. What this regulator is regardless of your shop pressure, this is regulated down to the pressure that's needed to control this unit. We limit that based on the components that are inside, and so we can regulate that right here on the face. The last unit is basically a lubricator for the reciprocating pump. The unit here is your oil for the lubrication, and as air flows through here, what it will do is pick up the oil through a drop system and drop it into the airstream to lubricate the pump for a long life of the pump. One key feature on all of our units is the nameplate. In the future, if you contact a factory for any information regarding this unit, it can all be tied right to this nameplate. This is a serial number for this unit. This is the year that it was actually built, and this is also the model number of the unit that you have. So each unit can have some flexibility to it. The different features are added or part of the design process. So if you need any assistance on your machine, if you'll take a picture of this nameplate and submit it to us, we can gain the information that we need on our end to be able to assist you. Okay, I'd like to talk about the controls on the HYDROPRO console panel. There's a lot going on, it's kind of busy, but once you break it down into the different circuits, then you start understanding what each components do. In the upper left corner here, these three components make up the vacuum pilot control. So if you have valves that are vacuum actuated, we can attach to those and control that from the console here. The other next to it is it's a positive pilot control, air pilot control, that just if it takes positive pressure to actuate your valves, that can also be controlled from here as well. Attached to it are gauges that can read the amount of either vacuum and or pressure that are applied. The base unit comes with a shop air test pressure control. You have an air circuit that can come and drive the pump and or be used for low pressure seat tests or low pressure tests with air. The other is for the water selection, we have a quick fill option. Basically allows water to be pumped as large a volume at large of a flow rate as possible directly to the inlet of the valve, or once the valves are full, we can direct it and then drive the water to the pump and the air to the pump and then build the hydrostatic test pressure. I have two block valves that sit just above the pump, so I can control which side gets pressure. Some tests require pressure only from one side, so seat test is a common shell test. If it's a shell test, I can determine which side to pressure from or both sides. So if I start from my pump and I follow the schematic, I can go right to the leak detection drip tube bubble jar system. If this is open or pointing to the side, it will allow water to flow. If it's closed, it will stop and allow me to follow on to, I have a drain. And as you can see on this unit, we have 4 ports available for pressure. When I attach this HYDROPRO console to a clamping table, that would consume 2 ports, an upper and a lower. And then you see it identified appropriately, top and bottom on our panel. If I don't have that externally, I can have four pressure ports, and I can test up to 4 ports at a time. So what these valves here control is just the flow to the ends of those hoses, whether they're attached to a clamping table or to a blind flange or to whatever your configuration is. I have a drain for the top and a drain for the bottom. And then on the top, I have gauges that match it for each pressure source. As can be seen, there's 8 gauges on the top. And if you look onto the panel, there's locations where these pressure gauges are indicated. So to tie the ones, so the vacuum pilot, it's got its own gauge. The air pilot has its own gauge. The low pressure air here has its own gauge. The system pressure right off of the pump has got a gauge. And then each 4 of the ports have a gauge. So the beauty of the HYDROPRO console is you can have as much or as little on this unit as needed for your application. So if you don't need 4 ports, you can buy it just with 2 ports. You can buy it just with 1 port. You can buy it without the actuation. So it's pretty modular in that aspect is you determine what your needs are, and we can provide it for you in the cabinet. What we're looking at is a standard seal plate out of a USB 12-150 ton. As you can see, the O-ring sizes are stamped here on the plate itself. They go from a 1-inch to a 12-inch flange, and so the sizes follow traditional sizing from a 2-220 to a 2-382. So if O-rings ever get damaged in the future, if you have a local supplier for O-rings, you can source them yourself based on the sizes that are identified. Yeah, I'd like to point out one of the features on the universal straight valve clamping tables is the patented interchangeable seal plates. The units come either with fixed or interchangeable seal plates, and they're set up for race-face flange seal. To interchange them, basically all we have to do is just remove them from the cradle, easily lifted with an eye bolt, and then we'll interchange. And today I have a RTJ style valve to test, so I'm going to be installing the RTJ seal plates. Once we've identified the proper RTJ seal plate for the valve to be tested, we simply pick it up and bring it over and install it into the machine. That's simple. Once we've installed the proper RTJ seal plates, we identify the ring to seal the valve, and then we install. The next step is to lower the valve into place, hold it against the stationary seal plate, and then what I'll do is extend the ram to actually trap the valve between the two seal plates, applying a low pressure clamping force just to hold it in place. Due to noise, I've got to turn the pump on, so you may not be able to hear me. Now that the valve's been clamped in place, it's got a low pressure applied to the ram to hold it in place. We need to apply the amount of pressure needed to hold the valve in place during the hydrostatic test. So in order to achieve that, we close the clamp interlock. We come to the chart. I know this is a 3-inch 900 class RTJ, so I go to 3-inch, come over to the 900 class, and determine how much pressure is needed to seal that valve during the hydrostatic test pressure of 3,375 psi. In order to achieve that, turn my low pressure pump on. I dial up the needed pressure. In this case, it's 2,800 psi. So I'll dial the pressure into 2,800 psi to hold the valve. Okay, now that I'm at pressure, I leave the pump deadheaded so that if there's any leakage in the system at all, the pump will kick on and indicate that there's an issue. That's a telltale. Once I have this clamped in, the valve can now be released from the crane, and the next step will be to tilt and position it so I can fill the valve with water. Now that the valve's clamped in place with the proper clamping pressure applied, I need to tilt it in order to fill the valve with water. The advantage of tilting allows us to completely fill the valve with water. As you see, the bonnet area is also a void that would have air trapped in it if it were just sitting in the horizontal. So by tilting it vertically, it allows us to put water in the bottom and push air up out of the top. We can talk more about that when we get into the HYDROPRO console and the controls on how to do that. And so we can test in this configuration, or if once it's full, we can tilt it back and test in the horizontal if that's necessary. All right, once the valve has been clamped in place, tilted, we're ready to fill the valve. I turn the main water feed on. The water comes through the filter. And I make sure I have the air to the system on. It comes through, it's got an oiler and a separator as well. And the first thing I do is follow the schematic on the cover sheet. My water selection valve is here, so for a quick fill option, it allows me to put as much water into the valve as quickly as possible. So I would turn to that section. Once there, I follow the line. If the drip tube is open, it will come out of the drip tube. So make sure it's off. If the drain's open on the bottom, I need to close it. Now what I'm doing is I'm following along the line. I'm coming up through, say, side A1, which I'm not using that at the moment, so I'm gonna close A1. And the USB is actually attached to the B1 and B2 circuits. So I'm gonna fill from the bottom of B1. Water's coming up through the bottom, going to the clamp table. The air is being pushed out of the top of the valve. It's returning on through the B2. A2 is attached to a different machine, so we're not using that. So I'll close both those ports off. And basically what I'm doing at the moment is just venting out the air as it's filling. Once it's full, it will show a back pressure, and I can look at the discharge of the drain and see that it's full of water. And once that's full, then I'll close this in, and then I'm ready to start building up pressure. Now the valve's full of water, I take and direct my water to the pump. I'm going to drive the pump by air, so I apply the air source also to the pump. And then since I'm doing a shell test, I'm going to apply pressure through side 1 or up through the bottom of the valve. For a shell test, I can do either one. The advantage of these two valves is to allow us to determine if I'm doing a seat test, I can apply pressure either from the bottom or from the top. That's a decision I make with what type of test I'm going to run. Once I get that configured, the train's closed, I just need to build up pressure, drive the pump, and I'm looking at the gauge here, B1 outlet, B2 outlet, and the system pressure gauge should all indicate the same for a shell test. So with that, I can start building pressure. Okay. I'm sitting at 3,400 PSI, which is 3,375 PSI is the hydrostatic test pressure for a 3-inch 900 class flange. So depending on the types of standards you're testing to, you can either keep pressure maintained onto the valve during the time of the test. In this case, I just deadhead the pump at the pressure I want. This is what we would consider an API 598 style test. If I'm doing an API 6D style test or to some other standard that needs me to isolate the pressure source, that's real simple. I can come up and just isolate the two valves that are going to the clamping table. Now I've isolated the pump. I can even bleed the pressure off the system, or I can also block it in here as well. So I have a double block there to isolate the pump from the valve being tested. Once we're done with all the testing, the last step is really to evacuate the water from in the valve so that I don't end up all over the shop floor. The easiest way for that is to isolate the water source. Make sure my pressure control knob is backed off. I'm going to use shop air, and I'm going to come in with shop air, and I'm going to go through side 2 and push air in on the top, and I'm going to drain the water out the bottom. So I just need to follow the configuration. So I'm going to come in the top, push the water out of the bottom. I need my bottom drain open. So with that configuration, all I do is dial in about 20 PSI of shop air, and what it will do is actually evacuate that valve with the water. Now, if the drain is visible, what I can see is it will initially be a full steady stream of water, and then at some point it'll be a water-air mix, so it'll spit, and then at some point it'll become mostly air. I mean, there may be some traces of water in the hose, but for the most part, that's the indicator you know that you're empty. There may be some residual water staying in the bonnet area, so one step might be to, once I think I'm empty, is to tilt the valve at about a 45, let the bonnet volume drain back into the main body, tilt it back up, and run the process again. If the valves aren't too big, or if you don't mind a little bit of water, then you don't need to do this step. Once all valve tests are performed and the valve's been drained of liquid, we tilt it horizontally to remove the valve. First step I need to do is actually attach the crane back to the valve in preparation to release the clamping force that's holding the valve in place. So the first step is to actually open the drains. We've got a top and bottom drain. I'm going to release the clamp pressure control valve, release the pressure to it, isolate the air pressure to that pump. I'm still sitting at 2,800 PSI. Then I'm going to turn on the low pressure pump. As soon as I move the clamp interlock to the release position, it's going to allow that hydraulic pressure to release. The interlock, opening both these drains, make sure that I do not have any pressure inside the valve before I release the hydraulic pressure. So I'll turn the pump on. It's going to be a little bit noisy, so cable. I just lift it up out of the way and get it ready for shipment. One thing to mention on all of our systems, the HYDROPRO console, the universal flanged valve and the universal straight valve testers, as well as the turnaround tester and others. All the components used in the circuits are within the working range, the operating range of the design of the components. We do not exceed the working range. So often you'll see components being put into a position where they're between the working range and the burst pressure rating of the components. That tends to shorten the life of the components. They're not really designed to be functioning in that range. Not to mention the safety involved as to the premature failure. So by staying within the operating range of the rating, the design rating of the components, we provide a 2-year warranty that's matched by none, and that's how we can stand behind that.